Hey, hello and welcome! It's me, John Park, and it's time for John Park's Workshop. And I was just fixing the title there. I had a typo in my little title there. Hopefully that's fixed now. Looks like it. Hey, thanks for stopping by today. And I am going to do a really silly thing and jinx it all by saying I think I may have better luck with my upload speeds today. Than I did 2 days ago on Tuesday. I had a bunch of problems. It seems like I have cracked the case and got on the phone with our cable provider and did a bunch of other things, and man, is it about 40 times faster, my upload bit rates available. So I haven't changed anything about this. I'm not upping the resolution that I send or anything like that, but crossing fingers, we will have no buffering on any of the services today. Yeah, I know, I doomed it, right? P. Curry in a hurry over there in our chat, over in the Discord chat, said, well, now you've certainly doomed it. Knock wood, that fixes it, right? Just knock a little wood. So, let's see what's happening. We've got I've got 3 different project updates that I want to take you through today. So that'll be something we'll look at. I've got some housekeeping types of things that we like to do. Maybe I'll do a real mini version of new products because we had no Ask an Engineer yesterday, so I don't have any graphics set up for it or anything like it did back when I was doing the Wednesday shows, but I'll at least show you a couple of new things that are coming or are out now. And let's see, getting questions. Some nice says, are you using a Pi-hole or anything in the middle? No, on this machine and this setup, I am not. I was using a service that was doing some of those sorts of things, not Pi-hole. That was one issue, a minor one, but the bigger one was just simply some reprovisioning needed to be done at the cable modem side, and I power cycled everything. And now I'm seeing 20 megabits per second upload speeds instead of like 0.4 that I was getting the other day, which were really, really sad upload speeds. What else? I've got a product pick of the week recap. I've got a CircuitPython parsec. I have a coupon code for you too. So you probably are aware that but I don't want to assume anything. You're probably aware that we have a store right here. This is Adafruit's store. We have other stuff too, but there's the shop. And if you check out the shop here, you might see we've got some new product picks up at the top. We've got some featured products, some learn guides that show off some cool products. And this is one of the ways, kind of the main way, that we keep the lights on here. We don't charge for content. We don't charge for tutorials. We don't put ads in the tutorials, in the learn guide. And so selling products, that's how we make a living here. So we'd love for you to find some cool stuff to get, and we'd love to give you a discount. So today's coupon code is Sunshine, and that's because it's not raining here in Los Angeles anymore, at least for a little while. So the coupon code today is Sunshine. That will get you 10% off on any products you buy in the store. It's not going to work on software, gift certificates, or subscriptions, but it's good on physical items. So if you head on over to the store, Adafruit.com, just head up to the shop there. On your way out, type in Sunshine. Sunshine is the coupon code. Type that in the little coupon code thing, and you'll get a 10% off on your whole cart full of stuff. So that's today's coupon code, Sunshine. What else? We've got job board, as you may know. So if you don't, you can head on over to jobs.adafruit.com. That'll help you out if you're looking to hire somebody or if you're looking to get hired. And as you'll see right there, we have a position open. It's the Employee Resources Assistant open position in New York at Adafruit headquarters. I believe, yeah, this is a full-time position. I believe it can be part off-site, part on-site, but it is a full-time. You'd want to be in New York. Don't give yourself a huge commute. And you can check out the details there by clicking on that. Also, you'll see down one below here is someone looking for a CNC programmer and maker at Machine Histories in Los Angeles. I don't know what that is. What is that? Why have I never clicked that? Looking for a machinist with a wide-ranging digital skill set, preferably in Rhino. Hey, I know Rhino. I don't think I'm leaving. But this is in Los Angeles, full-time fabrication job on site. And let's see, it looks like the link is a little goofy. I want to go check this out. Hold on, let me go to this other browser window. What did they call it? Machine Histories? Machine Histories. Machine Histories. Wow, my caps lock is on. Machine Histories. What is this? Oh, we can't go there, apparently. Something won't let me there. But I'll check that out later. Maybe you should too. It looks like it's a, yeah, where is that? It is near a Harbor Freight. Oh, that's good. All right, well, I will dig into that later. But check that out. Check out the jobs board in general. It's free to use. You can post positions if you're looking to hire someone. If you're looking to get hired, you can add yourself to the available for hire link up at the top. Let me go back to that page there. You'll see there's an available for hire link. You can go there and you can fill in info about the type of work you're looking for and the type of skills you've got and what you're open for. Let's see, what else? So Tuesdays, I've got that show right there. That's the JP's Product Pick of the Week show. Take something from the store, either old or new, and take you through it. Do some demos if that's applicable, show off all the little bits and pieces, which was the case this week because I showed off this Parts Pal and gave you a 50% off discount on it. 50% off. Not too shabby. This week I did have some streaming problems with it, but I've uploaded a clean copy now, so you can go rewatch the show if you want to, a clean version. I recorded it locally, so that's stored here before it went and got buffered up on the internet. And I also do a little 1-minute recap, so here's that. It is the Parts Pal. So Parts Pal is fantastic as a beginner kit for doing a lot of the types of projects that you want to do when you're learning how to use microcontrollers in particular, or just electronics in general. Just get this nice case, breadboard, jumpers, breakaway headers, LEDs, capacitors, resistors, transistors, voltage regulators, a 555 timer, an op-amp, diodes, the piezo buzzer, switches, slide switches, potentiometers, photocell, vibration sensor, thermistor. You'll frequently do these types of things with it when you're just first learning. Usually have your microcontroller and then it'll say, okay, plug it into a breadboard and then add these parts to these pins. So here you can see I've got ground going to one leg of an LED, the other leg of the LED is going through a resistor and then through another jumper wire back over to one of the pins, and I'm sending it a really basic Blink project. It is our best friend, the Parts Pal. Yes, indeed. All right. By the way, that one hung really neatly on my pegboard. I don't know if you saw that, but this thing does have a nice little hang tag. If you don't snap that off of there, you get to hang that on your pegboard for Emergency use only. All right, so let's see. Anything going on in the chat? Any questions? Andy Calloway's noticing CRT monitors in the back. Yes, we'll be looking at one of those. I've got a bit of an obsession with collecting CRT monitors before they go into the landfill, so I've been on the lookout and doing well adding CRTs to the collection. We'll take a look at something on one of those, the JVC. Let's see. Yeah, so next up, how about, this is a good time for a CircuitPython parsec. Okay. So this one is pretty specific. What I wanted to do today is show how you can determine which pins on your microcontroller can be used for I2S audio. So we have a couple of different products that use I2S audio standard. It's a really high quality audio standard that allows you to send digital to an amplifier, which can then send out beautiful, full, rich sound. And when you use these, you may need to do some juggling around of which pins you're using for what, because not every combination of pins can be used to do I2S audio. You have a bit clock pin, a word select pin, and a data pin, and you're not going to usually see those on the typical pinouts for a microcontroller. So this was actually a really cool little program that Kattni developed, and I'm going to pull up my code view here right now. What I'll do is I'm actually just going to run this again. So I'm just going to resave this to my little Feather microcontroller. And now what it's going through and doing is testing different sets of 3 pins to see if it will allow those to work as combinations of those 3 pins that you need for I2S. For any of them that actually pass this test, they show up in this list. So now you can just go through and find a combination that works for you for your project. Now there are a lot of possible combinations on a board like this Feather RP2040. Because it's just got a ton of pins and a lot of them can be used for this. But this is particularly useful if you have some sort of fairly small constrained board like a QT Py. And what it does in code is it's using essentially it's attempting to set up an I2S audio on a set of pins and finding out with a try and accept if that works or not. So the key thing here is this function called isHardwareI2S, and then it has inputs of 3 pins for bit clock, word select, and data. Then it goes through and tries pins that are available on the microcontroller, which is initially determined using the microcontroller library pin class. And then it tosses out some pins that are unlikely to be useful to you, such as a button pin, a switch pin, an LED pin. And then it gives you this nice list here. So now you can go through and find a set that works for you. I like to go to some of the digital pins here, some early ones, let's say. Okay, D4, D5, and A0. That's a nice little set that I could use. And so you'll see that this is a really useful program. You will find it just by looking up some of the I2S amplifiers in the Learn Guides, Adafruit Learn Guides. You'll find this sample code there. So you don't need to copy this off my screen. Just search around a little bit and you will find this really, really helpful code that Kattni created. It's called CircuitPython I2S Pin Combination Identification Script. So if you look for that, you'll find it. And that is how you can find out which pins on your microcontroller are going to be able to be used in CircuitPython with I2S audio. And that is your CircuitPython parsec. And it is no coincidence that I used that example today because I'm using one of those I2S amps in a project. It's in the C and Say, and I'll show you both the Fritzing diagram that I've been working on and the sort of prototype that's going on right now. And I'm using KB2040, and I don't know which pins I could use, and I already knew I needed some pins for a couple other things. I have a 10 I/O pins I'm using for buttons, so I needed to make sure I got that right before I went and fritzed things, or if you're not familiar with fritzing, essentially laid out the schematic for it in breadboard form. So really, really useful, and thanks Kattni for putting that together. I believe you can do some queries of all the pins capabilities, and then maybe get lucky picking a combination of 3, but this is a much better way because it does the work for you. It attempts to establish that I2S audio object, and if it succeeds, then we get that printout of the trio of pins you can use. Right on. Okay, so let's see. We've got I've got some updates. So first one is, if you remember last week, I believe it was last week, I showed my PCB design for doing the Pico plus a DVI HDI output plus the SD card reader and a little on-off switch that I can use for both DVI video projects and my Pico NES emulator. And I had originally built that emulator on a breadboard, and it was just a lot of wires. So I wanted to find a neater way to do it. So I designed the PCB. Those came in about 3 hours after my live stream last week. So that evening, a box of 5 of these little PCBs arrived from, where did I get it? For JLC PCB, I think. Oh, it's not on there. I checked the box that said don't write your name on this, I guess. Usually they put their name on there. Yeah, I got this from JLC PCB. It was $2 plus shipping, which I think the shipping might have been $18, something like that. And got them in like a week, which is incredible. I'll show you the board here. This is the unpopulated one. I'll show you in my little down shooter here. Let me get a tight focus on that. That's not bad. And let me boost that exposure just a little bit. There you go. So, I don't have a bunch of the parts sitting right here, do I? No. So, I have a fully built one that I'll show you in a second, and I'll do a demo on it. But you can see right here, I've got the surface mount pads to put the Pico, which has those castellated pads on the side. In fact, you can see here was a different project, but similar idea. Where I was just using some pins. I actually hung this off the edge here because I wasn't using these. But you can see here you can use the castellated, that's that little kind of arced cutout there on the side. That allows you to surface mount solder the board, which just is simpler. It also makes your routing of things simpler. You don't have any holes on the bottom to worry about routing pins around or traces around. So Pico goes here. And you can pretty much see the traces, right? I've got the enable or run pin is running up to a little slide switch up here. Let me get something to point with. There's a nice set of tweezers, that'll work. So this trace right here goes from the run pin to one leg of a slide switch, and then that center pin on the bottom is routed to this ground plane. So basically the whole bottom, other than where you see the darker green, that's all the ground plane there. So, so that is how we can essentially turn the thing on and off, regardless of how it's being powered. Then this is the SD card, which is an SDI interface, and not SDI, SPI interface, SD card reader. And then here is the DVI HDMI output sitting right here. So I'm gonna I'll unplug this one over here from HDMI and power and the game controller and show you an assembled one. So here you can see, I guess that's how I had it oriented. I'm going to switch this around. Here you can see we've got our DVI output, we've got our SD card reader, and we've got our Pico. Now you see the Pico is nice and flat on there. I think I could have done this one flat, but we have some components in the way. Maybe you could have done them all flat, but I put these up on some small nylon standoffs just so they were kind of nice and proud of the board there, which might be nicer for an enclosure. I haven't designed an enclosure for this thing yet. But your HDMI gets plugged in there, your power gets plugged in here, and here's your little SD card that you put your ROMs on that if you're using this in the game emulator mode. By the way, I did put the, it's kind of small, but if you're wondering what the code is I'm running, it is this GitHub right here, FHOEDE, FHODA makers / Pico-InfoNES Plus. And so it's a Nintendo Entertainment System, or Famicom emulator. It takes standard ROMs here. Now, I can't remember if I showed this last week or not, but this works out pretty well. This is the right-angled, sort of condensed version of the on-the-go cable splitter. So sometimes that's a Y adapter of cables. This one is nice. It just passes the power through here, plug-in power, and that's power and data that'll go to the Pico, and then it will send power to whatever peripheral device you have plugged in here. In my case, it's the PlayStation controller, and that allows the Pico to read the USB PlayStation controller that I'm using there. So there it is, and you can see I've got a whole bunch of space right here. I posted this, grab one of these, I just have one in here. I posted this thing to some social media yesterday. I've got a tangle of cables here. I have some dreams of adding support for a shift register based proper video game controller, which I have a OEM original NES controller here. I've got two of them that have become entangled. So this type of controller, you can get these real ones for probably 10, 20 bucks if you're going and finding them online. Sometimes way less if you find them at a yard sale. Sometimes a little more if you get them at a retro gaming store. But there are also clones of these that probably work the same and are super cheap. I know we have a SNES clone in the Adafruit store that's $5, and I think it would work just the same. This is the sort of D-shaped port that's on the NES controller. It's different than the SNES. I just got a pack for just a few dollars of these sort of replacement. This won't really work in an NES, but this is a port for that controller that should allow me to, if I make a footprint or find a footprint for that, I can add that port right there, which would be really cool. And then if we can get the code working with this emulator or other software to use the Pico to read the shift register, that is how this works. It reads the buttons kind of sequentially really quickly. This one chunk of data comes over that has all that info on it. That would be amazing, because this current version of this emulator really requires a specific controller. It's either the DualShock 4, the PS5 controller, or there's one USB clone controller of an NES or Famicom controller that's hard to find. I found one on eBay for 50 bucks. So if we could get that working with these have arguably the better compatibility from controller to controller. They're all kind of going to send the same thing. So it'd be really nice to get that on. So that was one of the reasons that I built this with some space. I wasn't quite sure what all this would get on it. Maybe some buttons, knobs, who knows? But that's my first run of that. And why don't we take a look at it? I'm gonna head over to the workbench. You can see I got this nice looking BVM working over here. It's actually a JVC, so it's not a BVM or a PVM, but it's a JVC branded version of a production monitor. And while this puts out, I don't want to confuse, I've shown this before on HDMI monitors. I figured it'd be fun to show it on a CRT. I'm using a real inexpensive, we sell these on Adafruit, real inexpensive HDMI to composite, which often looks less than optimal, just because a lot of TVs that accept composite don't really love the signal that's coming off of an HDMI thing. But hold on one second, I've got to put this thing on Do Not Disturb because something's blowing up in the text. This one happens to be working well. I think it's partly because this is a sort of professional CRT that can deal with non-240i and or 480i or non-240p images. So let me switch. I don't know if this will work right now. Will it? No. We'll just keep this camera small for a moment. So, oh, you know what? Actually, let's do this right. Let me get switched over to that down shot, that main view for a second, and let me goose this camera controller here so that it's, let me switch from the workbench. Okay. So HDMI out, that would be the same even if I weren't using this converter box. It works great on HDMI. It actually just puts pillar box black on the side, if I remember right, and the game is still at its original roughly 4:3 ratio. The adapter here plugs in. I will give it my controller. So that's this DualShock 4. Is that what this one's called? Dual something 4. I think it's dual, not DualShock, but Dual something 4. PlayStation 4 controller. So here's my USB power. And now I'll flip this on. And let me switch the... Oh, is this not working? Wake up thing? All right, I'm going to manually switch my camera. I'm not sure if that's unplugged on this end, but... All right, so over here, I don't know if I can zoom that in a little bit. There you can see a little closer. That's the sort of screensaver that's on this thing, but this is a, I'll turn that to face the screen a little better. This is just the file system that's built into the emulator for picking your games. I'll go grab something colorful and full screen looking. Let's see. Here's a Super Mario. So here it's doing a little handshake and negotiation, and this says 576p progressive at 60 hertz, which is nothing your regular TV would do. So I'm not sure how this all would work on a regular TV. But there you can see we got our Super Mario and Duck Hunt. This would work presumably with a real NES for a light gun, but not on the emulator. So there you go. There's Super Mario, looking pretty good. It's at full. What did we say? Progressive. It's like a 5-something line progressive scan, so we're not getting any of the sexy scan lines or anything in there. But it is a playable game of Mario that is being emulated right here on our little Pico. Some music. I'll die immediately. That's what happens when you don't pay attention. So can just hit both of these to go back out to the file list and pick different games. Just turn it off with the little switch right there. So yeah, camera switcher is down. So I'm really happy with how that turned out. It's just a nicer setup than the previous incarnation using the breadboard. David G, the emulator does not support the light gun. Well, you know, that's actually, I shouldn't say that. I don't know the answer to that. The light gun, maybe there's a USB light gun that it would work with. I actually have not looked into all of that. But light gun that I have is just a NES one, so I don't currently have a way to plug it into that, into this Pico emulator board because it's USB. So that would be the question mark there. Is there a USB light gun you can use or some other way? Andy Calloway, 576, that's PAL, isn't it? Yeah, good question. I swapped the output of that between PAL and NTSC. This TV does both, so it went through a little reset and played the PAL signal that was coming out of the box and the NTSC signal. So you got me. Yeah, it's not really what it's meant to do. What it's meant to do is show up on this TV, which I think I showed last time, just a regular HDMI, which is way more likely for someone to have in their house than some adapters and CRTs. But anyway, not bad for, I don't know what the total cost is. So the say $4 for the PCB with shipping. $4 for the Pico, I think $4 for the DVI thing, and another $4 for the SD card reader. So I don't know, call it $20 or less. It's not bad. Of course, you got to have the controller, which is why I'm hoping we can figure out something with that using a real NES controller. That would be awesome. All right, so that's the update on that. I'll probably go through another iteration of that PCB and noodle around with it some, and then put those files up if anyone cares to get one. Yeah, David G. Light gun would fail on a non-CRT screen anyway, exactly. It's a very edge case to use this emulator and a light gun on a CRT. So, yeah, P. Curry in a Hurry asks, so the light gun works by looking at a lit square when you pull the trigger. Yeah, because of the horizontal scan line that fills in every other line for one field and then jumps up to the odd field and does that. On a CRT, the program can actually see one lit up screen, one lit up pixel. And since modern displays are progressive, it just shows the whole image at once. We don't get that little sort of coordinate point that we want. I think there are light guns. I mean, there's the Wii doesn't use the screen at all. It uses a combination of looking at IR LEDs with a camera for triangulation, as well as the built-in accelerometers. I don't know about other light guns for games, how those work nowadays. Topbot says, use a Pico W, make a wireless NES controller that talks to it via Wi-Fi. That would be possibly laggy. It's a guess. I don't know, Bluetooth? I think most people don't mind the input lag on like a modern. I think all these are Bluetooth, right? Like the PlayStation controllers are all Bluetooth. Good question. Yeah, BLE, that would be cool. Okay, so next up, let's take a look at the N Say project. So I showed this last time. I've got my N Say, which is all pulled apart, but essentially it's a toy where you point the arrow at something, pull the lever or the string, and then it plays a... Oh, speaker just came off. That's okay. I kind of needed it too. Plays a sound, and so I'm replacing the guts of this, some of the guts, and keeping some of the other guts, so that we can put a microcontroller of our own choosing in there, our own amp, and use our own custom sounds. So here's what it's looking like right here. Let me refocus that. And so this board is, I showed this last time, there's essentially a high point on a plastic ring here that presses, depending on the dial position, one of these 10 rubber pads, just like a video game controller. And when those get pressed, they, in this circuit that's built in there, will make a sound. But I was able to use this with there's a common VCC point, and then there's 10 of these essentially digital I/O pins. So I have a demo running right now. Let me find power for this. Oh, geez, I don't have a. Let me steal one of these. Got to find a USB cable that's the right cable. So for testing, I just soldered these little bodge wires onto the traces that get contacts get closed by the little carbon pill on the underside of those rubber domes. And so I just, for testing, have it plugged into a Metro. And the Metro should light up. Let me reset it. Is that really working? Okay, it's powered on. I think that's a loose USB connection. That's not good. So I have the NeoPixel on here, should turn red, and then when I press, something's loose there, sorry. When I press one of the, oh gosh, let me get that cable out of the way there. When I press one of the rubber pads on here that's connected currently, I think I have 4 or 5 of them connected, we should see the NeoPixel change to green. There you go. So that is now working on a bunch of these. Yeah, I've got a really flaky USB cable here. Sorry, let me try it in a different point on that hub. Let's hope it's the hub. Oh, I think it is the hub. Okay. No? Oh, geez, it's resetting itself. I'm not sure why. Okay, so that's working well enough, as you can see. I'm just pressing different buttons on here. Right now, I'm just, any button press is counts as going to change the color of the LED, and that was just to check that my soldering and connections there were good. I don't know what's going on. Maybe this might be a faulty cable or something. So in putting this together, though, there's a lot of connections, so I decided I was going to put this, diagram this out inside of Fritzing, so I wanted to share what that looks like. Yeah, do I have a 5-volt for a barrel jack, AT Makers Bill? I almost went to grab one. It's a really good idea. Yeah, I think I'll skip it for right now, but yes, that's a good idea. I have suspicions about that USB powering that one. So here is what I did. I took a photo of the PCB from the toy, and then you can import that into Fritzing as an image, essentially. I think they call it a label. But you can make a label object and then go and find a PNG image. It actually even allows transparency so that you can see through, if something were underneath this, we'd see through it. Now, you can't bolt wires in Fritzing onto sort of nothingness. So I actually stick a bunch of these little perf board things underneath it and kind of hide them under there, make the smallest ones. I think these are the smallest ones they allow. There's probably some better object I could use. I don't know if there's a single pin object. So I think I might be able to group these things so they move together, but it doesn't matter for me right now the way I'm using this. But that allows me to place all of my wires on these test points that very kindly Fisher-Price put next to each of the contacts. Actually, this is a nice view you can see here of how this works. So you'll notice here's the common. This is labeled VCC. And in the original toy, this does in fact run up into the circuit in a couple places where it's using this for the exact purpose I am. It's measuring whether a contact gets pressed. By cutting this connection right here, can you see my mouse? Let me see. Yeah. By just cutting this trace with an X-Acto knife, now that VCC test point is out of the circuit of the toy. So that means I can use it freely without fighting whatever capacitance and things are going on inside of the circuit up here. So there's two places where those traces from VCC went up into the circuit, and just by cutting it right there at that sort of T-junction, it's now severed everything up here from the input section. So now I just run that VCC up to power on my microcontroller. Now you can see I'm going to use, rather than the Metro, I'm going to use something smaller, so I'm going to use a KB2040. And the rest of these points all just go to GPIO pins that are available on the KB2040. So I've got like 5 of them up here, 5 down there, and those are all just what, A0 to 3. Gonna have to grab the serial clock pin there, which I'm not using anyway, and then 2, 3, 4, 8, and 9. Now the reason I'm skipping 5, 6, and 7 is I'm not. Oh, those are in use. Okay. I'm confusing myself. Oh, okay. I'm not using 2, 3, 4. Sorry about that. 2, 3, 4 I'm using as you can see here. I've labeled them just to keep some sanity. The I2S audio. So this was the reason that I went and did that thing in CircuitPython with Cat Knees program to find out which pins I could use for I2S. So it looks like 2, 3, 4 as bit clock, word select, and data pin are a legit allowed set, so great. So I haven't even tested that yet. I haven't plugged that all in to test that, but I at least have some confidence in designing the layout here that I've got a reasonable choice for those pins. So then you can see here the I2S audio amplifier here. It's got those 3 control and I2S pins coming from the microcontroller. I've got it going to ground. I've got a resistor, I think it's 100K. Is that right? I can't read resistor labels. Yeah, 100K resistor running from V in to the gain pin. This chip allows you to change the gain. I think that gives me a 15 plus dB gain. This chip allows you to select the gain just by doing some different combinations of running that gain pin to other things. If it goes straight to ground, it's one thing. If it goes to the V in, it's another thing. So kind of cool. It's just a little selector, and then which value of resistor you use changes it. So, oh yeah, thanks, Foamy Guy said that's a helpful tip for sure to fake your. There's plenty of times when you don't have the real thing in Fritzing, and so you can just take a nice photo or make an illustration of it and throw it in there. Yeah, if you don't anchor these, there's no way to really keep sanity with these. Oh, well, maybe I'm lying. Oh, that went to my pin. Sorry, yeah. Let me make a new one. If you don't anchor those to something, I think you won't be able to put the bend in it. So if I just run this to kind of overlap on the image there. No, maybe something has changed. All right, maybe I don't need those. However, you can't just grab all those ends. So by anchoring it, we can do a move on all of that stuff, which is kind of helpful. So let me zoom out here. That's the reason. Yeah, now I've remembered. So if I go and select like this, I can move all of that. If we didn't have all those anchors, then that's what would happen. All the wires would fly, would stay behind. And then you'll also notice getting back to the I2S amplifier. This is the Max 98 357A, by the way. Same one I used in the Walk Person project. It's really nice. Dave G asks, did you check that those pins are I2S compatible? There will be a CircuitPython parsec for you if needed. Thank you. The power on this, one thing I found on the Walk Person project is I don't believe this amp will run off of 3 volts, or it may have some degraded performance. I think I was getting like crackling and stuff. I think it wants to be run off of 5 volts. And since the toy just has, you can see here, this 2 AA battery pack, and that really just runs right here to the board. So I've got the 2 lines coming off of that battery pack. Lamore's suggestion to me was, hey, see if you can run the whole project off of those AA batteries. So you probably could maybe get away on a fresh set of batteries running the KB2040 just by itself, maybe, if it's 3.3 volts. But I just don't think there's any way that that amp would be happy. So instead, I want to run 5 volts. And I'm using this cool little chip here that is the, it's actually not the one pictured here. We didn't have a Fritzing for the one that I'm using. But I'm using the Mini Boost 5 volt 1 amp. And in fact, I'll show you that in a second. The one I'm using looks almost identical. I have one right here. It's on a board right now. I'll leave it. I'll show you that in a second. But it looks similar, and the pinout's the same. So this worked out fine. It's just not that chip. So what this has is an input for whatever battery you're trying to run it with. I think it might take like 1.5 volts up to 5, I'm guessing. And then gives you a nice 5 volts up to 1 amp output. So it's this little Mini Boost chip, and it, in this case, is going to get roughly 3 volts when the batteries are nice and fresh of 2 alkaline batteries, dipping down into the 2.4 range typically, or if you're starting with some sort of rechargeables. Those usually live more like 1.2 even when fully charged. So it doesn't matter. I can feed it these 2 AA batteries. And you'll see here, I kind of use some convention to not have my red mean 2 different voltages, just to keep myself from getting confused. So red is the roughly 3 volts coming from the batteries, and then pink is what I chose. This is kind of wild magenta as my 5 volts. So you can see that's actually what I'm running to the breadboard voltage rails here. And then I'm picking up that as the voltage input on the Max 98357 amplifier. And just confirmed this morning, this does work. You can run the KB2040, even though it doesn't have a obvious voltage input on it. This pin labeled raw can be used for either grabbing 5 volts off of a USB if you have a need for it, or in this case, feeding 5 volts to it. So what this does is it makes an end run around the 3 volt circuit if you jumper the jumper on the bottom of the KB2040. So there's a little jumper there. It's the only one on there, and it's just for this. It's just, do you want to use the raw pin? If so, we can then feed this 5 volts, and it seems to run fine. Much of this is theoretical, because literally all I have working right now is powering it up. It's all I got to. I have basically this circuit built on the breadboard. I don't have any of the inputs from the toy running into it yet, but let's jump over here. Actually, before I do that, I'll, as promised, show you the chip I'm using, the little Mini Boost I'm using. 1 second. Mini Boost. And here we go. So it is this one. It's the Mini Boost 5 volt at 1 amp, TPS 61023. I just happened, you can see when I bought them. I bought them July 29 of 2020. And by some miracle, I put them in a drawer in one of my parts bins labeled Boost, and they were in there, which, wow, so glad. So this gives you a little chart here of what it'll run on. So 2 to 3 alkaline batteries is pretty typical to run it on. And it tells you what kind of current you get at different voltages. So I'll probably get up to 800 milliamps if I have 2 fresh alkalines in there. And maybe, I don't know if that's the minimum. It's probably not. It probably goes lower than 2 volts on this. I think there's a newer version. Yeah, this purple one, I think that's newer and has a nicer silk screen than the one I'm using. When was that update? You'll see sometimes these history notes. As of November 2022, this was updated with Penguin, so it's got the really nice silk screen. Although it doesn't look bad on the one I've got over here. So that's the one I'm using. It's $4. Let's jump down to the Workbench camera, and I'll show you what this looks like, and just a proof of concept that it seems to power some things, which I'm glad of. Let's put that over there. Turn you off. And excuse me while I zoom us in a good bit. All right, so what's going on here? I've got a little 2 AA battery holder, which I just found right before the show. In fact, I had to, I don't have it here anymore. I had to jumper a 4 AA battery setup to, sorry, let me zoom this camera out. There we go. To make it work earlier, and then right before the show I found, oh, I do have a 2 AA. So it's 2 AAs. I'm using one of our little wire connectors there to run that to some ends of some jumper wires to plug it in instead of this is stranded wires on it. So that's going, you can see ground is going to my ground rail. V in is going to V in on the TPS 61023 mini boost, ground to ground. 5 volt is, now I'm not using pink wires here in real life, sorry. I don't have any. But there's my 5 volt that is on this rail, which is running into the raw pin on the KB2040, and then that's going to ground. I don't have the amp plugged in at all yet. Actually, I've got ground on there, but I didn't fire this up yet. And then you can see here I'm using this enable pin, which is kind of cool. There's an enable pin on the mini boost, so you can just ground that and it turns the whole thing off, so power doesn't go any further than this, which is great. You know, often you'll power your project with the microcontroller's enable pin or run pin on a Pico. But that means that this thing would be on all the time doing its thing and wasting heat and energy. So nice that this has this little, you can use any minimal little switch here. It's got no current, barely any current running through it. And there we go. I flip it on and I got blinking lights over here. You can see the green LED. Flip it off, flip it on. So sorry, that's as far as I've gotten other than planning it out. And verifying that at least I've got, I think, a workable solution for using the battery, AA battery alkaline box that's built into the toy, which is really cool. I've done a few of these projects where I've gutted a toy to some degree or another, and I've always had to come up with my own battery solution or power solution for it. So if this works, I'll definitely keep this trick in the bag of tricks for taking over toys and other consumer electronics that have a little battery pack in them. Because usually it's 2 or 3, taking those and turning them into the 5 volts that this will run on is great. And we have other solutions for different voltages depending on what's coming in and what you have going out. But this one should be perfect for this. So let me turn that off. And let me know if you have any questions or thoughts on that. I'll check in with the chats. By the way, let me know how the stream itself is going from your end. It looks, at least from a bandwidth perspective, things are pretty good. YouTube is saying it's good health. It doesn't love the bit rate though, so that could be some settings on my broadcast side. So yeah, there was a question about the goal of this toy. I'm actually trying to keep everything except for the brain. So I'm going to use my own amp and my own microcontroller, and then the toy has the nice input buttons that I'm reusing, and I will need to use a power switch or some really clever sleep code in order to not have it run all the time. I'm assuming the toy has like some really efficient sleeping code, so it just wakes up when a button gets pressed. And so then I'll be able to play WAV files off of the RP2040 through that amp and the existing speaker that exists in the toy. Let's see. Yeah, the exterior should look stock. Not sure how I'll do the power switch for it if I do. And that's right. Yeah, I need to get this toy ready in time to send to baby Ada. DJ Devon 3 says the raw is only for the input power, right? It doesn't shift the whole board to 5 volts. That's right. I think that the most of what's going on in the KB2040 is still 3 volt logic. It's just that that pin can normally be dragging 5 off of USB for purposes of someone who's got other stuff plugged in, particularly on keyboard projects, how it's designed. So yeah, I think I'm running the 3-ish volt alkaline into the mini boost. 5 volt comes out of that, goes into the raw pin on the KB2040. Raw pin converts that to internally 3 volts or 3.3 volts. I think that's how that works. If anyone knows otherwise, let me know. All right, good, okay. And then last thing I wanted to do is give an update on the LCARS project. So this is the, let me clear some stuff here. Talk about what this is. This is a panel from a spaceship in the the Star Trek, sorry. I didn't do that intentionally, I promise. In the Star Trek universe, they have this computer interface system that has this really beautiful style, really recognizable geometric style. This is a panel that you're not going to see it that well right now because it's not being backlit. But these are meant to be backlit on the set. A friend of mine wanted me to turn this into a kind of a piece of wall art. So it's essentially a vinyl sticker, which you can see some of the indents there of the vinyl process, and then a piece of frosted acrylic. So you could just backlight this and it looks great, but my friend wanted it to actually have some animation to it. So let me show you what this is looking like with a, oops, wrong camera, sorry. What this is looking like with a matrix portal and 2 pretty high density matrix panels, RGB matrix panels. I'll zoom out a bit. And I cannot promise this will look good on this camera. I may have to turn lights down and stuff. It looks good in real life, but on cameras it's been difficult. So matrix portal, I designed and laser cut a piece of acrylic framing just to hold the 2, this is 2 panels, hold these 2 panels together as if it's one, just because we don't sell one and I couldn't find this kind of density in this 2-to-1 ratio, which is essentially what I needed. And then I've also made a sort of light blocker to go on top that'll prevent bleed from sort of this one cell to another. And let me plug in power. So I've got a 5 volt, 4 amp power supply for the RGB matrix. And then I've got USB-C to power the matrix portal. And let me find that over here. And this is sort of the recommended thing with these portals. You don't really want to try to run all those LEDs just off of the USB-C connection. Yeah, so you're going to see a bunch of blinking there, which I probably can't get rid of. Let me just try once to, I'm doing this blind, but let me see if I can find a shutter. Doesn't like any of those, sorry. Let me go the other way. Okay, that's good. It's a little glitchy, but now you can at least see some of the intentional animation that I have going on. So what I found out as I looked into it a little more, and typically the outer frames are still on these, and the let's see, let me turn this light off. Yeah, sorry, it just does not look good on camera. I'll have to find ways. This will probably make it really blinky. Yeah, that doesn't really improve it. Oh, that's not bad. Okay, so if you ignore some of this blinky here, you can see here we got some nice elements popping in and out as if data is being calculated and important information is being vectored to your vector or whatever you want. What I'm doing is I've designed a sort of larger outer frame so it'll hide the electronics and plugs and allow me to do an enclosure front and back that I'm probably going to do just out of acrylic, maybe with a wood veneer. And that'll allow this to, just prop up on a desk or something like that, or hang on the wall, depending on how you want to do it. So I do have, let's see if this will work. I do have a button on here that just locks it in place. So this is not animated at this point, other than the flickering you're seeing. I had a dim mode that looks terrible. I tried just dithering the pixels to see could I, because I don't think you can dim these panels. So I just wanted to see, okay, what if I just put a sort of dither pattern on the pixels? Will that look dimmer? So it looks like that, but it really shows through. I could probably, if I got this whole thing further away, that might work, but I think we're not. I think I'm going to bail on that idea and just go with, sorry, here's the brightness of this, and you can just go between animated version or not. The way I'm doing it is just with a sprite sheet. So there's an SD card. Is there an SD card? No, I don't think I have it on an SD card, but I might. I might switch that to an SD card. I think this thing has an SD card reader. But you can plug the matrix portal into your computer. There's just 2 bitmaps on there. There's the one that's just the still, although I could probably in code make that simpler and just have it go to the first tile of the sprite sheet. And then there's the sprite sheet. So sprite sheet right now I think has like 9. Hello. So sorry about that. The batteries died in my mic pack. 2:04. Okay, it was 3 minutes ago, ish. Yeah. Okay. So good. I'm glad that wasn't like the whole time I was over there. Let me know what the last thing I said was, and if you saw anything that I was talking about that seemed like something you want to know. Hopefully, I was just talking about how the BMPs work or something like that. Please fill me in. Yes, sorry about that. That's funny. That was at a high enough level at the beginning of the show that I thought. Unfortunately, these mic packs just show you 3 bars of battery health. I wish it were finer grained than that. And yes, I really need to find a good solution for the one that's docked over here. It doesn't need to use batteries, but let's see. Oh yeah, so good points. So C. Grover palette fader can be used to dim the panel now without dithering. That's awesome. I will definitely check that out. Dave G also says you should be able to dim it with colors, right? So if I made it 120, 120, 120, that's another way to dim stuff. Has 9 is the last thing we heard. Has 9 what? 9? Oh, okay, I was talking about the bitmap tile. It's the sprite sheet. Okay, it has 9 of these little images. These little, what are they? 128 by 64 pixel images. I just have copy pasted them and then I deleted out some of the blocks there. Let's see, catching up on anything else. Thank you all for trying to tell me. I was hearing ba-doop, ba-doop, and I should have paid more attention. Lars chews through the cable. It did ding, and I heard it. Thanks, AT Makers Bill. Good. Yeah. Backup wired mic. That's the receiver side of this setup. And, yeah. Cool. We're caught up. I'm so glad that wasn't like the entire time I was talking about that. I'm glad it was a dead battery. Yeah, it did sound like you were just really engaged, like having a good conversation back there. Okay, I think that's gonna be it. Oh yeah, was there another question? I thought there were some other questions in there I missed. Let's see, there's a cute dog. Oh my gosh, eyes on that thing. Can't hear you, Gina, I know, I'm sorry. A flickering Enterprise would be upsetting, wouldn't it? Yeah, actually, Pico in a Hurry, someone asked about doing touch for that. What would it take to do? Or some other way of knowing when you're touching that screen. Pico in a Hurry, do you plan to do parent voice samples for the See and Say? Actually, Lamora said she wanted city sounds, since they usually have cows and farm sounds and they live in the city. So if you got suggestions for city sounds, that's what I'm going to go for. Good. Okay, I think we're caught up. David Essa says, maybe you could set up a TTS for the chat. I don't know what that is. Is that like a captioning system? Teletype? I don't know what that is. Let me know what that is, what you're suggesting. And I'll wait for anyone to chime in with that, and otherwise that's going to do it. Oh yeah, there was text-to-speech. Text-to-speech for the chat so I could hear you? Oh my gosh. Maybe that'd be a role that we can add for some people who wouldn't abuse it. I'd abuse that. That would be fun. Okay. Hey, thanks everyone so much for stopping by today. It's been fun giving you some updates on these projects and doing all the other things we do. I don't want to forget to give you that coupon code again. If you want to support Adafruit by buying cool stuff and support your own projects and learnings, or give gifts of cool electronics stuff to other people, why not get 10% off while you do it? And you can do that today by typing in sunshine in the coupon code field on your way out of the store. Oh, and you know what? That's also reminded me that I did say I wanted to just take a quick look at some products. So let me jump back here. Products, new products, view all. We've got 2 new products in the store this week, and they are 2 variations on a USB cable. So this is a woven USB-A cable that has magnetic tips. So you can take the little magnetic tips, put them in your device, and then just bring the cable head near it and snicks into place and provides power and data. We have variations in 1 meter and 2 meter lengths, and these come with a USB Micro B, a USB Type-C, and an iOS Lightning connector for the end. So you get all 3 of those with this. You don't have to get separate cables. It means you can plug in one cable that maybe you bring 3 different devices by to charge, and this will do it. So here is the 1 meter long version. You can see it right there. Very handsome. I like these woven cables. And there's a data sync and power passes across this for up to 5 volts, or rather 5 volts up to 2 amps that you can use on that. So we have that 2 meter version, and then we also have, or the 1 meter version, then we also have the 2 meter version. This also says that you have to be aware that this is going to be limited to the 5 volt, 2 amp. You're not going to get higher voltage or higher current power, whatever, over USB-C. And I think it's a minimum set of connections on data compared to what you might find on some USB-C cables. So it says here, please note this cable only carries the power and data plus minus sync cables, not the extra set of pins on USB-C. That means it's not compatible with some of the other devices that we have, USB-C things. And I don't think you'd be using that for lightning cable types of things that usually have USB-C on the other end. This is USB-A. All right. So those are our new products. 2 new cables. Go pick some up and get yourself a discount on the way out by typing in sunshine. And that's because it's sunny in Los Angeles. Big surprise, I know, but it was really rainy. I think that's going to do it. Thanks, everyone, for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Please tune in tomorrow to check out a deep dive with Tim Foamy Guy. Tim's in the chat, so you can ask him, hey, what you working on, if he knows. And then we have other shows lined up starting again next week. Come on by in all of the usual Adafruit broadcasty kinds of places. Thank you, everyone, and I will see you next time. Bye-bye.